We just talked about the formation of disaccharides through these O-glycosidic linkage or these glycosidic linkages. Now, here are a total of 3 different disaccharides that I want you to be familiar with. The first one is sucrose. The next one is lactose. And finally, maltose. Now, sucrose is a disaccharide, and if you look at it, we've got actually 2 different ring structures on it. Sucrose is a disaccharide of glucose and fructose. Lactose is a disaccharide between galactose and glucose. Maltose is 2 glucose subunits. Now, throughout all these different sugars, or what makes these sugars different from one another, is that, well, the linkages that exist between them varies a little bit. If you look at sucrose, we've got carbon number 1 on one sugar going to carbon number 2 on another sugar. If you look at lactose, you've got a beta linkage between carbon 1 and carbon 4. If you look at maltose, you've got an alpha linkage between carbon number 1 and carbon number 4. So in addition to the composition of those sugars being different because they have different sugar subunits, linkages are also a little bit different from one another. Now, polysaccharides. Well, polysaccharides are large numbers of monosaccharides connected by tons and tons of glycosidic linkages. These are also known as glycans. These are used as forms of energy storage or as structural materials. They can be divided into 2 classes, homoglycans and heteroglycans. So are they the same subunit over and over and over again, or is it different subunits and repeatedly? Homoglycans are composed of one type of monosaccharide. Some examples of homoglycans are starch, glycogen, cellulose, and chitin. So starch is your glucose storage in plants. It's a mixture of amylose and amylopectin. Glycogen is glucose storage in animals. So it's both starch and glycogen are made up of glucose. The difference between them is the linkages that exist. Cellulose is a plant structural fiber, and chitin makes up the exoskeletons of arthropods. So what does starch look like? Starch is composed of 2 different sugars. Amylose, which is an unbranched polymer of D-glucose linked through alpha-1,4 glycosidic linkages. So we have these repeating elements over and over and over again. The other component of starch is amylopectin. Amylopectin is a branched form of D-glucose. We've got alpha-1,4 and alpha-1,6 linkages. So starch is a combination of these 2 sugars, or these 2 polysaccharides put together. Cellulose, which if ever you think about cellulose as something that humans can't digest, the reason for that is because of this beta-1,4 linkage. So the way that you derive or you look at that bond is, where is this hydroxide group that was used in forming this glycosidic linkage? Well, it's pointed up. If you remember, going up for that anomeric carbon, well, that's an indication that you're talking about a beta sugar. So we've got this up linkage, and then carbon number 4 is going down. So we have a beta-1,4 linkage. So ultimately, though, what this means, or what's significant about cellulose, is these elements repeat over and over and over again and enable this complex network of hydrogen bonds that allow cellulose to be so strong. Now, chitin is an unbranched polymer of a aminated glucose. So this is beta-1,4 glycosidic linkages. But then on carbon number 2, we have this modification making this repeated elements of D-N-acetylglucosamine. So these glucosamine elements repeating over and over again. Okay, so those are the things that I wanted you to get after for sugars. No monosaccharides and no poly and disaccharides. I gave you 3 disaccharides that I wanted you to know. And the key is to be able to recognize that. I'm going to give you the structures of sugars, but most of your questions will revolve around, well, what's the difference between these 2 sugars? What makes them similar? What makes them different from one another? All right, well, I hope this was helpful, and I'll see you in the next chapter.